Okay, so I'm given a graph of f. So this is the graph of f. We can notice that. Assume that all critical points, points of discontinuity, points of inflection, and end behavior can be observed from the graph below. Okay, asymptotes are indicated by dotted lines. All right. So the limit as x approaches -4 from the right. So as x approaches -4 from the right, that's from this side, my function value goes off to infinity. F prime of -8 would be here, so that slope at -8, that would be 0. The limit as x goes to 5 from the left of f of x, so as x goes to 5 from the left, my f of x function is coming into -1. The integral from -8 to -6, that's this area here, just a rectangle, height 2 and base 2, so this will be 4. The second derivative at x equals -5, so let me delete some of this stuff. When x equals -5, that's here. And so the derivative is just linear, so the second derivative will be 0. Because the concavity is 0, because it's neither concave up nor down, it's just a straight line. So it has no concavity. Okay, the limit as x goes to 0 of that thing, that's like the definition of derivative. That's going to be f prime of 4. And so at 4, I can see that the derivative is 0. This is like a slope of a secant line from 6 to 7.3. So I'm looking for the slope of this portion of the graph. And so if you go over 1, it looks like you go up a half. So the slope of that is 1/2. The limit as x goes to infinity of df dx. Okay, as x goes to infinity. So as x goes to infinity, that's this way, right? And it's looking for the limit of the derivative. So it's just linear there. So that linear function has slope 1/2. And then f double prime of 0. So that is actually where the concavity changes from concave up to concave down. So that is an inflection point, which means the second derivative is 0 there. Find a value of x for which f is continuous but not differentiable. So continuous means I don't have to pick up my pencil. Differentiable means the left and right hand slopes are the same. So this cusp here will be an x value where it is not differentiable. Evaluate each of the following integrals. Show all of your work. Okay, so an antiderivative of 1 plus cosine x will be x plus sine x. I want to evaluate that from 0 to pi. So that'll be pi plus sine of pi minus 0 plus sine of 0. Sine of pi is 0, so I'll just have pi because that's equal to 0, that's 0, obviously, that's 0. Okay. For the next one, I want an antiderivative of e to the x minus 4 sine x. So an antiderivative of e to the x would be e to the x minus an antiderivative of sine x is negative cosine. So I could change that to a plus 4 cosine x plus c. Since it's not a definite integral, I could have a plus c there. Okay, this next one is going to be, again, the fundamental theorem of calculus part 2 combined with chain rule. So I'll have the square root of 2 times ln x to the 4th plus ln x plus 1 times the derivative of the inside function that I plugged in, which is 1 over x plus c. No, not plus c. For the next one, I'm going to need to do a substitution. So I can let u be the inside part, 5 plus 2x cubed, then my du will be 6x squared dx. So I can see here that I have my square root of 5 plus 2x cubed. That's my square root of u. And then I'm going to move that x squared to the back. I'll have x squared dx. And in order to get my whole dx to show up, I can put a 6 here and a 1/6 there, which is just multiplying by 1 in a creative way. And now I can see that I have everything I need. This is going to be u to the 1/2, and then this is my du. So 1/6 integral of u to the 1/2 du. So an integral, an antiderivative of that will be 1/6 times u to the 3/2 times 2/3 plus c. So this will be 2/18 or 1/9. And then u, we can go back to what u was, 5 plus 2x cubed to the 3/2 plus c. Okay. The next says a box of volume 100 cubic inches with a square bottom and a top. So it has a bottom and top. It's constructed out of 2 different materials. All 6 sides of the box will be constructed. The cost of the bottom is 4 cents per inch squared, and the cost of the top and the sides is 1 cent per inch squared. Write a formula for the surface area of the box as a function of a single variable. So the surface area will equal 2x squared, because I'll have the bottom and top are both x squared, plus 4xh. So I know that the volume of the box is 100 cubic inches, so I know that 100 is equal to x squared h. So I know h is equal to 100 divided by x squared. So I can write my surface area as 2x squared plus 4x, and instead of the h, I can write 100 over x squared. Then it says, write a formula for the cost of manufacturing the box as a function of a single variable. So the cost as a function of x, well, the bottom of the box is 4 cents per inch squared, so it'll be 4, and the area of the bottom is x squared, plus the top is 1 cent per cubic inch or square inch, so it'll be 1 times x squared plus, now I have 4 sides that are all equivalent, so it's 1 cent per square inch times the 4 sides that are x times h, and then I can write my h as 100 over x squared. Okay. Then it says compute the minimum cost of constructing the box and write your answer in the space provided. So I'm going to simplify this, and I'll get 5x squared plus 400 x to the minus 1. And so c prime of x is equal to 10x minus 400 x to the minus 2. If I set that equal to 0, I can add the 400x to the minus 2 over and multiply 3 by x. So I'll have 400 is equal to 10x cubed, divide by 10. So x is equal to the cube root of 40. And so I need to figure out if that is actually a minimum or not. So I'll put that on my number line. And I can compute a number smaller than cube root of 40. I don't know how big the cube root of 40 is. It's about 3.41. Okay, so if I plug in, I want to plug into my c prime values bigger than and less than that. So if I plug in 1, say, so 10 times 1 minus 400 times 1, I get a negative value, which means that my cost is decreasing. And when I plug in a number bigger than cube root of 40, like 4, say, so I'll have 10 times 4 minus 400 divided by 4 squared. That gives me a positive value, which means that my cost is increasing. So it is a minimum. Okay, now to find my minimum, find the actual minimum cost, that'll be C of cube root of 40. So I need to plug cube root of 40 into my cost function. So when I do that, I get $175.44. Wait, hang on. Is it $175 or 175 cents? The amount, the units of what I had was in cents. So this should be cents. So $1.75, I think, is the answer. Okay, so this says that the function a is given by that. Determine the coordinates of the point of inflection. So to find an inflection point, I need to find when a double prime of x is equal to 0, and then I'm going to look for the concavity on either side, or see what if a double prime is positive or negative on either side of those possible inflection points. Okay, so I've got my function a. If I want to find a prime of x, I'll have to employ the fundamental theorem of calculus part 2 in coordination with the chain rule, because I can see that one of my bounds is a function of x, not just a plain x. So by the fundamental theorem of calculus part 2, I'm going to have square root of x squared, I'll plug in the x squared for t, minus 10, and then all of that will be multiplied by the derivative of x squared, which is 2x. So I'm going to go ahead and simplify that. So square root of x squared becomes positive, and it says that x is positive, so I know that the square root of x squared is positive x. So that'll give me x minus 10 times 2x, which is 2x squared minus 20x. Okay, and then a double prime of x will be 4x minus 20. So if I set that equal to 0, I'm going to get x is equal to 5. So I want to check on either side to see if a double prime is positive or negative. So for numbers bigger than 5, 4 times that number minus 20 would be positive. For a number smaller than 5, 4 times a number smaller than 5 minus 20 would be negative. So I know that on this region, a is concave up, and on this region, a is concave down. And so 5 is a point of inflection, so that is the x coordinate. To find the y coordinate, I need to compute a of 5. So that will be the integral from 0 to 5 squared of square root of t minus 10 dt. So that will be the integral from 0 to 25 of t to the 1/2 minus 10 dt. So I need to find an antiderivative of that. So the power of t is going to go up by 1, so I'll have t to the 3/2. I'll have 2/3 t to the 3/2 minus 10t. And I want to evaluate that from 0 to 25. So that'll be 2/3 times 25 to the 3/2 minus 10 times 25. And then minus, when I plug in 0, I'll just get 0 for the rest of that. And so there's my final answer. If you want to plug that into a calculator and get a value, you can. Let's do it. Okay. So 2/3 times 25 raised to the 3/2. So when you do that 3/2 power, you just need to make sure you put parentheses around it. Minus 10 times 25. I got negative 166.66. Or if you wrote that as a fraction, that's negative 500 thirds.